Um, I'm Travis. I'm editing the Evil Martians blog. I'm going to help tonight. This is Bytes and Bytes, developer meetup. Bytes and Bytes 3. Talk about that in a minute. This is the third one. It's been in Lisbon, Istanbul. Now we're here. Had to come here. A little bit about Evil Martians, who organized this event. Evil Martians is a product development consulting agency that works with startups and established businesses while also creating open source products and services, open source based products and services. Oh, thanks. There you go. Second slide. You see dozens of libraries and tools for devs and tools and plugins for UI designers. We specialize in open core products that help developers big time. And so our website is evilmartians.com. You maybe want to go there. And let's see here. Twitter @evilmartians. You just need to go here. Click follow. And I illustrated how you can do that with this red arrow. You just click it. You can go there. Next slide. And we're hiring. We're hiring. If anybody is interested, this is the QR code. I'll leave that there, but we'll talk about that later. Yeah. So what's going to happen here tonight? You're going to have 3 talks. They're pretty cool. I already heard them, but you're going to hear them now. After each talk, there's going to be Q&A, so you'll have time to do that. The talks will be about 30 minutes long, approximately. Q&A, maybe 5 minutes. After the second talk, we're going to have a little break. Come on in. There you guys. We're going to have a little break. You can go get some of the food outside. We can't bring the food in here, right? So you can't bring food in here. You have to go out there and eat it. So we're going to have a break after the second talk. There's no smoking in here, no eating in here. What's your name? Yeah. And so, like I said, we'll talk about this hiring at the very end. Let's just go to the first speaker. This is Nina Torgunakova. She's a front-end engineer at Evil Martians. And so her talk is going to be about, how many hours do you think you spent doing that? 400? 400 problems. So should I spoil the talk? We didn't, like, because I have it written down. Okay. So if you know websites like HackerRank, LeetCode, 400 problems, right? In 1 year? Yeah. So she's going to talk about that. And this is for engineers at every stage of their career. If you think like, is it useful to go on here? Is it just for the interview and so on? She's going to talk about why it's useful for you to do it all the time. So take it away. Oh, that's good. There's something I forgot to talk about. During this talk and during the Q&A, there's going to be prizes for like interaction. So I want to show them now. We have these badges. You see this? So during Nina's talk, there's 3 challenges. So if you answer the challenge correctly, it's going to be very difficult because there's like 100 people here. So I'm not sure. We're just going to have to do like the honor system. Who is the person that raised their hand first? You'll get it, and I'll deliver it to you. And then during the Q&A, each speaker will have another badge. So they'll pick their favorite question, and you'll get the badge that way. Somehow it's more fair. Okay, so please clap again now. Let's do it again, please. Yes.
Oh, my clicker, Travis. Do you have a clicker? All right, that's cool. Hi, everyone. Before I start, I want to ask you a few very simple questions. No prizes for them. So, have you ever tried this site? Raise your hand if yes, please. Oh, so great. I didn't expect this result. Okay, and who tried this one? It's awesome, guys. Or maybe someone prefers this one? Cool, I see. Great. If you are not familiar with none of these sites, let me explain what I'm talking about. LeetCode, HackerRank, CodeWars, and other coding platforms, they are all sites, places where programmers all around the world can solve different tasks in the sphere of computer science. Most of them are short, and you can solve them relatively quickly, like in a half of an hour or even less. And most of them are focused in the sphere of algorithms. But you can also find many interesting questions in the sphere of databases, artificial intelligence, math, and so on. Given these tasks are very popular in companies all around the world, different live coding interviews, including such popular like Amazon, Facebook, Google, and others. And because of this, there exists a common opinion. If you are able to solve such kind of tasks, you are able to receive any dream job that you want. But a few months ago, I wrote a thread in Twitter where I told why and how I solved more than 400 LeetCode problems in a year. And my main goal, I wanted to show that I was solving not because I wanted to receive some dream job, although I accidentally managed to do this last year. And now I'm a front-end engineer at Evil Martians, and I completely love my work. But I was solving 400 problems, not because I wanted to receive a job offer. And my main goal today is to show you how solving algorithms could be extremely useful and interesting thing. Because success on job interviews is just the tip of the iceberg. is just a small piece of all benefits that everyday solving problems can bring to your life. But when I talked with other programmers about the thing, I realized that many of us don't see all these benefits. And this is because of huge myths that existed around all these coding platforms. Let me show you today these myths and some real fact about algorithmic problems. Myth number 1. All such problems are boring. Well, really, why we need to pass over again and again the stupid binary trees when we can do something more interesting? Like just chill after work, or maybe make our own pet projects, or even repaint and renaming buttons. Very amusement thing. I can claim it as a front-end engineer. But jokes away. In fact, there is a really big range of options, really fun and tricky. Well, of course, if you're picking again and again some difficult tasks, you will get bored very soon. But in reality, you can choose between something more interesting options. Let me show you some really intriguing tasks from LeetCode. I love this one, the first one. Imagine that we have an airplane with exactly 100 seats, and exactly 100 passengers are boarding at this very moment to this plane. And imagine that the first passenger managed to lose his ticket for this plane, and he just picked the seat randomly. And all next passengers after him, they also, if their own seat is free, they pick this seat, or if it is busy, they pick seat randomly. The question: can you presume the probability that the last passenger will get his own seat? Consider that there are 100 seats and 100 passengers. Any assumptions? It is the whole room of developers. Raises your hand. It's not so big range of option from 0 to 1, so I don't know. Someone? We have golden badges. Yes? Sorry? Other? 100? No. No, not exactly. Closer, but not. Yes? Oh? Okay, I didn't understand, but maybe you also was closer. Half of the, No? 50%. Yes, great. Really, if it is not a private jet, and there is more than one single seat in the plane, the probability will be always the same. And it doesn't matter if there are 100 seats or 1 billion seats or 100 billion, I don't know. It will be always the same, the half of the point or the 50%. It's like a famous anecdote about meeting dinosaurs in the street. Either you meet, either you don't meet. But in fact, the solution for this task is for a bit complex than this anecdote. You need to use mathematical induction here to solve it and prove. I highly recommend to try it on your own. But let's move to the next task. More easy. Imagine that we have a circle of pizza, and we are waiting our friends for dinner. And we want to divide this circle of pizza into some equal slices. Really practical-oriented task, right? And each cut you can do in 2 different ways. Either you do it by radius, how it is shown as the first circle. Either you can do it by, sorry, I supposed to say diameter. Diameter as the first circle. And by radius. It is shown as the second circle. So imagine that we are waiting for two friends and we need to divide the circle of pizza into 3 equal slices. The question is, what is the minimal amount of cuts we need to do to receive 3 equal slices? Hands? Yes. I don't know who was the first, but... Well done. You have chances already, so it will be next task. So yes, we need 3 cuts to have equal 3 slices from this one circle. And the answer is 3. Yes, but what if we have a really big circle of pizza and we have 99 friends? What will be the answer if we have 99 friends or 400 friends or 4,000 friends? It is also very interesting to brainstorm it in your mind. And the solution for this task is really short, and you can write it just in 2 lines. And it doesn't matter if you write in C++ or Python. Yeah, so try it. And the last one task, I also like it. Imagine that we have a row of chips that lay on a table. And we want to move this row of chips into one single column. So, and we need to move the chips sequentially, so chip by chip. And the rules of this game are you either can move one chip for 2 positions, and then you will pay nothing. Either you need to pay $1 if you want to move the chip for 1 position. Left or right, it doesn't matter. So it will be like this. So the row of 3 chips transform into a column with 3 chips. So consider the rules that movement for 1 position costs $1 and movement for 2 positions costs none. What is the minimal total cost in dollars to move these 3 chips into 1 column? You already have your page. Okay, who else? Okay, this? And what is the answer? Yes, of course. Yes, I repeat the rules. It's quite simple. You can move 1 coin in 1 position, left or right, and you will pay $1. Or you can move the chip in 2 positions, and you will pay nothing. Okay, you. Okay, okay. Well, the scheme is the next. It's really answer $1 single, and it is quite easy case. But imagine that we have not just 3 chips that lay into a single row, but we have million chips that lay into few rows, like 10 rows, and you need to move them into 1 single column. That is more tricky one. And I also recommend to try it and come back to me with answer this case like million chips. But let's move forward to the next myth. Many programmers say that these tasks are all complex. And moreover, this complexity is useless. Like, why we need to know any certain algorithms when we can just invoke a certain function in our language, and so on. But if you have a more difficult case or you need to write your own something function, you know that it could be useful. But let's move forward to the answer useless or not useless. In fact, about complexity, there are many levels of preparation on LeetCode, and you can pick questions, consider your level. Even if you don't familiar with some language, some programming language, you also can pick some easy tasks and it will be good. I will show you this one. There is no deceiving it. You really have two integers and you need to return the sum of them. No deceive, really. But even if you're faced with some more difficult tasks and you don't manage to solve it today, you don't really need to do this. In fact, you can postpone the tasks. You can pick some easier ones before it. You can read your theory before you pick this task. Because in fact, process of solving algorithms is very similar to process of learning languages. I presume that when we started to learn English, we don't start with something like Shakespeare's poem. It's too difficult. I think we are starting with something like this, very easy step, like dictionary. And the same is this process of solving algorithms. Many programmers see themselves when they solve some complex task, like it is a call, like it is a chance to prove themselves. But you don't really need to prove anything because it is a process of learning. And even if you are a programmer with years of experience and many knowledges, you also need some time and additional experience to get used to all these specifics of the tasks. And it's completely okay. So just pick the easier ones and then increase the difficulty gradually. Let's move to the third myth about all problems are time consuming. And sometimes you need to spend many hours to solve one single task, and it could be devouring and so on. If you ever had been debugging something for many hours without any result, you can know that it could be very demotivating. But the solution of this problem, if it is not your paid work, but you do it in your free time, is very simple. You can just limit the solving to prevent wastage of your time. For me, I spent no more than 40 or 60 minutes in a day for one single problem. And if I didn't manage to solve it in this time, I just postpone it to another day. But it could be difficult for many programmers. Why? Because many beginner programmers look at themselves when they're solving something like they are summarized. Like, I won't Google anything for many hours. I won't look at other people's solutions. I will do it by my own, and it doesn't matter how many hours it will get. And it is a big problem, actually, because, as I said, all these tasks are mostly short, and you can solve it quickly. And if you spend more than an hour for a single task, it means that you do something wrong. Like maybe it is a lack in your theory, and maybe you need to pick some easier tasks before it, or just you need to erase your white spaces before it. because the process of solving algorithms is more about marathon, not the sprint. And you need to do it like your habit. If you will solve many tasks again and again in one day, and you will burn out very soon with this approach. But also, if you will miss some days when you have like a routine of this solving tasks, you will also can miss your progress, because it is important to have it like your habit. You can do small portions of solutions every day, but permanently. And LeetCode also says when you solve some daily task, I think many of us remember like consistency is the key, and I see you tomorrow. That's a good idea. And let's move to the myth that I dislike the most. Many programmers say that these problems are not connected with real work, and you need them really only for job interviews. And they're also complex, so it is useful and it's boring and we don't need it. But I disagree with this opinion. I want to confess that I never was on such coding interview when you are sitting in front of your laptop and you're striving to solve something, and many people are looking at you at this very moment. I think it's not so great. And at Martians, for example, we have a more healthy approach. We have 3 difficult questions for our front-end engineers and candidates to front-end engineers, and they have 24 hours to solve these questions and write their answer. And it is completely offline, and I think it's more healthy approach. But let's return to our myth about apply it or not apply it. I want you to imagine that today you will return home and you will start to solve algorithms. And you will do it every day for 1 year. And I want you to imagine which result you expect in this 1 year and how your knowledge will increase in this 1 year. How would you look like in this 1 year? Not like this, I promise. In fact, in reality, you will notice that you will write your code really faster because tasks have their own patterns. They have similar things that we need to write again and again. So your brain and your hands will remember this. And in a year, you will write some things automatically without additional thinking. For example, recently I solved some not so complex task about traversing the tree. We have a tree and we need to traverse it in zigzag level order, like from left to right and to right to left, and then again left to right. Not so complex. I solved it in 5 minutes. But maybe a year ago, I can draw something like this in 5 minutes. So yes, my speed increased very noticeably. And the next result, it is also connected with the last one. You will see fewer bugs in your code. Why? You will have more resources because you will have more time to not just solve the task, but also think how to solve it better. And it's really useful. And also, it's not so enjoyable to see again and again these red words like wrong answer when you submit your solution. So you will automatically think about how to consider edge cases and so on. And yes, that's how beginner lead coders looks like when they're striving to submit their solution. The next result is you will explain your decisions really better. Many programmers are wondering when I say that these platforms can improve not only your technical skills, but also your soft skills. Why? Because these platforms are platforms and they usually have some sections like discussions or solutions where programmers share their own solution and you can look at other solution, you can publish your own, and I highly recommend to do it because I noticed when I tried to publish my own that I'm practicing in explaining, and in my work I am able to explain my decisions better. So it's great. Just try. The next result is you won't be afraid about some complex work task because the more you're solving, the more you're learning different patterns, the less you will be afraid to take something more difficult. I will show you the example of some working task. This is an auto-building network map for data centers. If you're familiar with data centers, spine leaf architectures, and so on, you can know that it is a very easy examples, and in reality, there can be thousands of devices with many different complex connections and many levels, not just 3. And the task was to visualize very clear, very beautiful, and if I hadn't been solving some tasks with graphs, with maps, with data structures, I was more afraid. I will be more afraid of this task. But I felt more confident in this field. And now I'm not afraid to take some complex working tasks. Yes, I'm front-end engineers, but we also have complex working tasks, right? And the last but not least result, you will expand your horizons, and not only in the programming field. When I started in school, I hated geometry. I just didn't understand why we need this science. It's completely useless and so on. But when I solved some tasks with geometry topic, I realized that it also can be interesting. And I just enjoyed it. And the same with the game theory. I became familiar with the theme also, and I understood that it's really cool and great to solve questions about this, and also read some books about this. So you really can expand your horizons, and not only in the field of algorithms. If I return back in the past, this were a moment where I solved the first question. I will give myself a lot of recommendations and tips because I learned a lot from my mistakes. And today I'm ready to show you the list of tips that can keep your motivation and will help you to achieve the better progress. We are all different people. Some of us are morning people, and some of us are starting to wake up only in evenings, and it's okay. When I started to solve tasks, I realized that my highest level of intellectual activity is in the mornings and in the afternoons. And in the evenings, I prefer to do physical activity. And consider this, I choose to solve these tasks before my main work in the mornings. I don't suggest you do the same, but I highly recommend to keep track of energy level during the day for your different activities. Because productivity is not about violence against yourself. You really can be a productive person being just more attentive to your body and your brain. So just try it. The next tip with solving algorithms is trying to always consider constraints, thinking about edge cases, and try to test every your action. It is connected with the thing I told previously, like you will see a fewer bugs if you will think about edge cases. So I can show you example how you can do it. For example, we have a very easy task, like we need to traverse a tree. And we know that there can be n amount of nodes in this tree. Which question can we ask to understand which constraints we should consider, which edge cases? We can ask something like this: what if the amount of nodes equals 0? Could it be in this way? And we can ask the description of our task, and then when we will know the answer, we can consider it in our code. So a fewer bugs, it's cool. Tip number 3. I already said about trying to explain your solutions. It is really useful, but it is also important to try learning from other programmers. Like you can check and learn from their solution. Not just copy, but learn. And there could be a tricky thing, because sometimes you can find a solution from a programmer that is much better than yours. And it's okay. It could be demotivating, but you should think about you don't know the background of this person, and you really don't need to compare yourself with him or her. Because how do you know? Maybe they spent in the programming field like 30 years, or maybe they wasted 5 hours to solve this task. You never know, so just don't compare yourself with others. And my last tip will help you with this, because when you track your progress, you can better compare yourself with your previous yourself. It will also help you to track the progress and keep your motivation, because you know about your growth in this way. You can do it in many different ways. For example, you can create a list in Google Sheets and just draw 30 squares for each day of the month and just paint it green when you solved or try to solve some question. If you are a more conservative person like me, you can use for these purposes just a piece of paper or your planner. It's just a matter of taste. Just pick the option that you like the most. And it is also quite useful not just to track, but also to discuss tasks, solutions with other people who also share your ideas. You can find such people like in the circle of your colleagues or friends, or you can post your ideas in social networks, or you can talk with your grandma about this if she knows who are front-end, who are software engineers. It's just important to have some people on your side. I want you to believe in your ability to solve algorithms, because the hardest thing in this activity is just to start, and then consistency will help you, because it is a key of success. So don't give up, make small but permanent steps, and then you will achieve a great progress in the programming field. Try to start it today. Thank you.
Now you're going to have Q&A, so if you have questions,
Yes, yes, I hear. Yes, that's better. Uh, yes, of course. How many tasks I need last year in my working sphere? Yes, I understood. Let me think the second. I already show the one task that I had, and it was the one of the biggest. Like I spent on this task like some time. But also, it is regular needed, like when you need some data structures, not like arrays, for example, but maps. And also, uh, maybe it was a few tasks last year, but there was a lot of tasks when I also saw the impact from LeetCode. For example, from LeetCode, I understood like uh, almost all JavaScript methods for arrays. Like I know exactly how them works right now from LeetCode, because you are not practicing them so much in your real work maybe, and also you want like understand and memorize them all when you're just reading them in documentation from these methods. Yes, yes, it's a great field to practice in it, like practice different points of view in your language. Thank you. Yes. Yes, I repeat the questions. Did I use any unit tests for checking if my algorithms work? Yes, the structure of LeetCode right now is you can write not any, but very big amount of test cases for your code, and just many types of input data, and then try it. And nearly in all times, LeetCode consider like all edge cases, and if you solved something wrong, you will understand it very quickly because it will be wrong answer for some type of input data. So no, I didn't write special unit tests. Maybe just a few times, or when I tried to solve some task and also visualize it. Like a few months ago, I saw the task uh, with mines. Uh, not remember very well, but the point is I was solving it in React also and visualize then. And then in such cases, I needed like some kind of tests, but not unit. So I think you can go without it. Like don't write them because LeetCode is very smart, maybe smarter than we now sometimes. So I just go without it in most cases. Thank you. I see, I see. Yes. Yes, it's cool. Yes. Essence. Copilot. I need to understand if you mean use Copilot if you didn't able to solve the task for 5 minutes? No, no. I recently received a message from one of my followers. Like, I tried to use LeetCode and not Copilot, ChatGPT, maybe. I don't remember, but like artificial intelligence. I think why not? But also I received messages that it is not always working properly. So I think we need to check it. And if we need to check it, we also need some knowledges before it. So it is a complex solutions like what we need the first. But I like the idea. Any other tasks? I saw I saw the hand. Yes. Well, thank you for the questions. I repeat the essence of the comment. Like code wars is also can be better than lead code for many people. Yes, the good alternative. Well, I choose LeetCode only because it was a pretty white theme. I like white themes, yes. But I also know that Code Wars and others are also good, and why not? You can pick everything you want. About the questions, like when you strive to solve something for many days and you couldn't. Uh, it based on theory in most cases. So each task is quite small and it is about one or maybe two single topics in all the sphere. You don't really need to strive to solve something for many days. If you understand that you already read theory, you solved some easier tasks, and you also don't able to solve it. I also faced with it when I solved dynamic programming tasks. They can be really hard in the way you need to understand how to, what is the approach to solutions. It could be really tricky ones. I really recommend to look at other solution and really read it a few times to understand what this person meant. Because also in solution section, there are a lot of good programmers who describe their solution very well. And when you read them like a few times or 10 times, you can feel like, oh, I'm stupid, but it will work when you pick the next task that is similar to this. So don't give up in any way. It's no shame in looking to other solutions because you are learning. And if you haven't got a job interview tomorrow, I think no, you just in the process of self-development. So thank you for the question. Last one. We can discuss.
You want to say something else? Okay. Thank you. And so, Nina, please think about who was the favorite question, and we'll give the badge after the talks. I think I have to say a couple things. A lot of people came in after we started, so welcome. You might notice that there's a lot of people in this room, so maybe some of you are feeling like kind of hot, But if you know what I mean, like the temperature. Some of you are probably feeling kind of cold. So we've got like this conflict between like the cold people and the hot people. We can't really open these windows because it becomes too cold. So we're aware of this, but we're going to take a small break now, and then we're going to come back. So we have food out there. Let's take like a 5-minute break. I don't know what that gesture means. Was that a 4? You want to do a 4-minute break? 3-minute break? Okay, well, let's take a 3, possibly 5-minute break, and everyone can go out here, and if you're stuffy, you can have a chance to step outside here, or you can have food, and then we'll come back. So thank you. Come on in. If you're outside and you want to come in, this is probably a good time to come in if you're outside. So our speaker will start here in just a second. I'm going to introduce him, and then he's going to start. So if you're like talking right now, just politely ask you to kind of, well, not stop necessarily, but you have to be quieter because I can hear you. Anyway. So this is speaker number two. This is Pasha Kalashnikov. He's a backend engineer at Evil Martians. And oh yeah, I was supposed to ask, can everyone hear okay in here? Like, can you hear it? Yeah, you can hear that there. And about the temperature, I'm gonna ask again. It got really cold in here. Did anyone think so? Because we opened the windows. It got pretty cold. You don't think so? You're surrounded completely by people, so maybe you got like lots of body warmth. So everybody's got like different temperature situations going on. Anyway, Pasha Kalashnikov, backend engineer, Evil Martians. He said that I can pretty much let him go for it without too much introduction about this topic. So it's about Ruby not being slow, he says. So here's Pasha. Come on and please. Yes.
Yeah. So many new faces, so many old faces. Some faces are very old. Hi, my name is Pasha, and I'm glad to see you here. And today we're gonna talk about how Ruby is not slow anymore. But some introduction, some notes in the beginning. What is going on? Everything is okay. All pictures, not this picture. I think we should do something with this picture. Just give us, please, a second. Okay, let's try one more time. All pictures you will see on the slides are generated by several modules I used. And you know, I've tried to write my speech with the ChatGPT, and I became very sad because this speech was very good, and I decided that I'm not ready to replace myself with a machine. That's why, please listen my broken English. Yeah, it's my face here. Yeah. Okay. This handsome guy is me. And I'm a backend engineer in the Evil Martians, and I have used Ruby for around 11 years. Peter, we should do something with this. Please help me. Thanks. Maybe we should. No? Okay. Okay. If you say so. Okay, I'm Pasha Kalashnikov. I'm a backend engineer in the Evil Martians, and you can find me by this username. Some accounts in Russian, some accounts in English. Don't forget to subscribe. Yeah, and of course, if you speak Russian or can listen to Russian, please listen our podcast that I've been doing with my friends Natasha Musina, who is here, and Dasha Bajanova. It's called IT Way Podcast. I think it's the best ever audio show. And I'm not the only one, I hope. And if you just starting your studying in the programming and IT, please start start listen to our podcast from the episode number 0. Okay, enough introductions. Let's do the content. Ruby developers, please show your hand. Oh, so many of you. Could you please tell me what the very first thing we hear from people about Ruby who chosen another language to use? Who told this? No. Who was the most loud? I need this man. I need this man. I have a gift for you. It's you. It's you. Where is? Okay. Please come to me after the talk. After the talk, of course, I will give you a badge. I hope it's gold. Okay. Of course, Ruby is dead. Not just Ruby, you know. Okay, Ruby is dead. I've heard it 10 years ago. I've heard it in 2015, 2017, 2019. Then COVID came to the stage, and those people needed to remind me that Ruby is dead. And you know, Ruby is dead for 10 years, yeah? And I think that somebody is wrong, and I think it's not me, because Ruby is not that. Ruby is the good language. A lot of people use Ruby. Please see this room. But the second thing we hear about Ruby, new colors, nice. The second thing we hear about Ruby is too slow. Yeah, this is the image from the module. Ruby is slow. Ruby and definitely is slow. Okay, Ruby is too slow. And you know, every time I hear this, I try to understand what they talking about. You know, I ask questions, try to understand, and figured out that almost all people doesn't understand what they're talking about. You mean what? Is this slow? Please, Ruby developers, tell me. Is this slow? No. It's black. It's not slow. Okay, it's not slow, you know? It's not slow. When we see it again, I will I promise you that it's not slow for some reason. I think it's going to be a long talk, you know, very long. Can we do something with this? Now I need it the most. Nina, could you please? The matrix came on the stage. Could you please ask somebody outside from this good place about this problem? They told us that there's another one thing. This another one things. What do you think about highlighting? Is in your IDE? There's good one, not good one. Okay. Maybe we should reset somehow this, because it worked. It worked nice. Hmm? No, we're talking about Epson and its technology. Okay. Okay. Is this slow? Could you please tell me? Okay, I will answer. It's not slow. Okay. Is this slow? Please answer me. Slow, yeah. Sleeping is slow. You should sleep faster, yeah. No, it's not slow because it's just words. You know, it's just words. Words can be slow, can be fast. It's just letters, and the first thing you should answer these guys that words and idioms can be slow. But what's slow? Let's when I ask those guys about this, they tell me something like virtual machine. Okay. By the way, they mean interpreters and runtimes too. Okay. What? What? Virtual machines, interpreters, and runtimes slow. MRI, MRI and YARV are slow. JRuby and JVM are slow. Or Rubinius, God save you, Rubinius. Rubinius is slow. No, they don't know what to answer because they just listen some here that Ruby is slow and just repeating it. And I think that good programmers won't come to you with Ruby slow. They will try to understand what is going on here. And the problem is in certain runtimes and interpreters. And that's why, please remember, guys, if you have somewhere that Ruby is slow, you should give those developers the one proper answer. Go. Go hack yourself, because today I will show you how to use new technologies in Ruby development to speed up everything everything we have in Ruby applications. Because we need only this to build them. We need only this and this. Okay, let's talk about Rust. Let's talk about trust to the speakers who promised you the fast Ruby. Okay, 2022 was the year of Rust. We've got ported YG to Rust. We've it's an issue, yeah. We've got cargo builder added to the bundler and Ruby gems. The whole world said us that please use Rust and Ruby in Ruby development, and we heard this. Okay, let's make a little proof of concept of the fastest JSON parser in Ruby. Yeah, as you know, the most popular issue we have in Ruby is slow JSON parsers, and every time everybody tries to solve this, and we will try to. Okay, I thought that I should do some live coding session here, but I decided that make live coding sessions in 30 minutes talk is not a very good idea. That's why the video. Okay, this is my video with my coding sessions with a couple of with a bit montage and special effects. Okay, I will try to run it. Okay, where are you? Here. Oh. Okay. Just a question. Do you see what's going on here? Yeah, I will try to stop. Yeah. Okay. Let's do. Nina, could you please? Could we start a video from, not from YouTube, from our backup here? I think it's gonna be better. Where is this? Please. help me with it. Thanks. We will start video from the laptop. It would be better, yeah. Thanks. Or yeah, it works. Okay. And remember, I told you that live coding is not a good idea. Yeah, we can't start the video. How can I make it? Oh, nice. Okay, I think it's better. Yeah. Okay, now we are creating new gem with the default command with the extensions, with a Rust extension. We called it Ultimate JSON. There is no ever Ruby gem with such name, so let's see what we've got at the very beginning. Okay. Okay. We're interested in two files here. This is lib.rs and cargo.toml. Lib.rs is the main file with our Rust extensions. Extension. We won't create new files here. We will have all code in this file, and I will just copy paste here. Yeah, something like Copilot, but better. And I will talk a bit later what's going on here, and we just copy. We won't copy. We just open cargo.toml. It's like a gem file, and add the libraries we need. Okay, what is Magnus? Magnus is library that provides us useful bindings between Rust and Ruby. Yeah, third JSON. It's one of the most popular JSON parsers in Rust, and Serder Magnus. It's a library that provides us serializers between Rust types and Ruby types. For example, between hash map and another type, I will tell you what is it. And tiny JSON, we don't need it because I forgot that we don't need it. Okay. Okay, we added this libraries. Yeah, and of course we need to do some changes in our gem spec. I just make it faster, and all we need then is just write bundle exec rec compile, and now the magic. It's bundle install if you, but for Rust. Okay. We have a couple of warnings here, but it's not production ready. It's just a proof of concept. The main thing is green. Finish it. We have built Rust extension. Okay. So now I want to show you some lines. Oh, some lines of my code, and these two lines, line 1 to 1 and the next line is very interesting. As you can see, we defining class ultimate JSON, and next we define singleton method pass JSON. We defined them in the Ruby. After these lines, we can use this class and this method of this class in the Ruby. And now I will try to use it. I create a simple Ruby script, something like that. What about pass.json method? It receives as a first argument the file name with the JSON. Yeah. Okay. And what do we have? We have result that k value container something like that, key-value container that can provides us a methods to fetch values from this JSON. Okay, and just believe me, there is K1 in our test file. Okay, I figured out today, in 2 hours before our meetup, that for some reason the window with the test JSON wasn't recorded. That's why you just see that I just copied my 300 megabytes JSON to the project, and now we just run our script with the Rust extension. We should add this flag to tell the Ruby to use this extension and the file name. Okay, 300 megabytes of JSON, and what we've got nil. Why we've got nil? Because, as I told you, the JSON file wasn't recorded to this video. I figured it out in 2 hours before meetup, and I tried to test every type of JSON, like numbers, strings, and null. Do you guess what what value was in the key 1? It was null. That's why if this thing show us nil, it works. Oh, please believe me. Okay. It works, and let's add a benchmark. Okay, adding a benchmark. Of course, I remember all of it. Yeah. Okay, and now we run it one more time. This is a little bit faster than it was in real life. 8 seconds. 8 seconds. What do you think? 300 megabytes. My machine was something like it's a big fast machine. What do you think? Is it fast? It's fast for Ruby, and now we will see how it's first. I prepared a little script. I will show you later with the most popular Ruby parsers like JSON, the default parser, RapidJSON, and OJ. Yeah, and all of them are running. Yeah, and we run our script with this new script with default JSON libraries. Okay. And Rust script working. Now it's real time. It's real time. 8 seconds. Okay, and we wait for the Ruby. Don't see its place. We don't need this. Okay, and we still wait for JSON parse. The same file. I've tested it with the 1 gigabyte, and it goes away. Okay, JSON parse operation is 16 seconds. Okay, we wait the next one. Wait. It could be long. Oh, rapid JSON, 17 seconds. Okay, waiting one more. Okay, OJ was something about 17 seconds. The main thing, we should know that it's just a proof of concept, and we must remember that JSON parse, default JSON parser, rapid JSON, and OJ is a great products. It's a great gems because they return to us Ruby hash. Yeah, and I did not tell you that I return a Ruby hash. I did tell you that I return a container, and I will explain what is going on here. Let's please open my code. Oh, Oh, I understood. Okay, just give me a second, please. We did have time for this. Okay. Oh, it's become. I kind of. Yeah. Okay. Uh, what do we have here? I want to explain what is going on. It's not. I I made a hack. We open this librs file and just give me a second. Uh, the one proper way to parse JSON file in Rust and send it to Ruby, it's parse it with JSON, convert it to Rust hash map, and then serialize with JSON to the rhash type. What is rhash? I'm sorry? Bigger. Yeah, thanks. I forgot what am I talking about. The proper way, yeah. And we bring the Rust hash map and convert it, serialize it to rhash. What is rhash? Rhash is a type that's provided by Magnus. I remind you that Magnus is the library that have useful bindings between Ruby and Rust, and Magnus rhash is like Ruby hash, yeah. And when you convert your Rust hash, serialize your Rust hash map to the Magnus rhash, you can use this object in Ruby. Yeah, it's kind of difficult, but it's not. Okay, and when I implemented it, I understood that the serializing between hash map and Magnus rhash is the slowest action in my code. Moreover, this action was slower than JSON parse, than OJ, and the rapid JSON. And I became really sad, and then my friends, the good Rust developers, told me that there is another way, and we decided to make to not use to not parse everything from JSON to the hash. Why? Why do we need in Ruby 300 megabytes hash? What we're gonna do with this? We're gonna sort it. It will be slow. We're gonna do something else. What's the one action we have with a big hashes, big hash objects in Ruby that must be fast? What the one action? Fetching by the key, it's hash. There's the one action that must be fast, and when you trying to load a big JSON object to your memory, you need to maybe the only thing you should do is fetching fetching value by the key. And I decided that I can just implement. I don't need to serialize my JSON to the hash. I just can implement a little object that I called JSON value. Sorry, where is it? So many code. Oh, yeah. I can implement the class ultimate JSON with just one method, fetch. And what is going on here? We parsing big JSON with the Rust, send it to the Ruby, and this object, it's not a hash. It's just our ultimate JSON. You can name it. You, you can name it as you want, and we have method fetch, which and we can use it to fetch values from this JSON. And of course, when you receive this value, you can fetch one more time from this value, of course. And that's all. That's all. And by the way, if you need right now, of course, it's proof of concept. I published it. I published this code and decided to not show you. But I just implemented it in 2 days, and I don't understand anything in Rust. Right now we can work with big JSONs, and I think it's a good proof of concept that we can implement everything and bring Rust to our lives. Okay, we don't have much time. Where is my presentation? Here it is. We don't have much time. That's why just. How can I? Rust, Ruby, please. Oh, okay. We will skip it. Okay. What should I say in the end? That we identify each other, ourselves, as Ruby developers, Golang developers, Rust developers, and other. And I think it's good, but I think it's better to be the developer without limits. To not be afraid to trying to use Rust in your application. To not be afraid trying to use Go. Maybe Rust developers will create more beautiful and handsome code with the Ruby and leave everything they need in the Rust. I think it's better to be developer without the limits. Okay, it was Pash Kalashnikov, backend engineer with Martians, please. Oh, whew. I think it's time to question. Yeah, it's time to question. Yeah, what? Okay, as I told you, to be engineer without limits is better, and of course, when Ruby developers decided to create the useful tools to use Rust in their code, I think it's time to use more languages, and Ruby is the best in things which where it's the best. And I think we should just continue to use Ruby in these things, and in things where we can be faster, we can use Rust, we can use Go, something like that. Yeah, I think we should. I can explain how does it work. Sorry. Yeah. What was the first question? The first question I answered was, should we all of us go to the Rust? I answered no. And the second question, how does it work? How does it work? I tried to add this stuff to this short presentation, and it's impossible. We can talk about this after the meetup. Sir? Yeah, no. I didn't test it at all. I need more time. We just decided that we need to try Rust between Ruby 2 weeks ago, and something like that. Thanks. Okay, you, please. You, you mean what about trying to? Sorry, I don't understand your question. Mhm. Oh, I don't need. I understand. I don't need to compare because Rust is better, of course. um, uh, I will prepare my second speech on somewhere with this information. It is in my plans to make a big table, something like that. Okay. Yeah. Mhm. What do we have in Ruby? Mm. Okay. I think types in Ruby is a very hard question. I think that I did not. Um, I'm waiting. I wait for the for the big guys who decide how we should live with types, yeah, in Ruby, because I think it's very difficult. It's a very complicated question, and we discuss types in Ruby community for more than 10 years. I remember this discussion 2012. Um, it's very complicated question, and if the big guys didn't decide something, that I think that uh, um, I'm not ready to answer to this question because you you know uh, um, I'm just a fan. If I'm just a fan of Ruby, and if and I w- uh, I didn't thought about it. I think I should make my own opinion about this. Thank you. I didn't thought about it a lot. Okay, Nikita, your question. I I I don't repeat questions. Yeah, I know. Mhm. From from the Rust to Ruby. I'm not so experienced in Rust to no. Yeah. Mm. You know, Okay. What thing we should bring from Rust to Ruby, and what the best thing I liked maybe in Rust? Okay. Um, 5 years ago, and you remember it, Nikita. I started to use Golang. Yeah, and it and using Rust this year was the same thing, because every time Ruby developer trying to use something like static typing or something like that, we are trying to understand, why, what should I do with this? Where's my freedom? Please return. Where's my toys? Please return my toys. Where's and it's the first day. It's the first day. It's the first date. First date with Russ. Please return my toys. And the second date is about what do you have more, because if you uh, took my toys, you should you should return to me something more than I had. And I tried to find this. Um, I think I should better understand what is traits, how to use traits, because in this code you saw this code. I just implemented them, you know, and I think I should understand better what is traits, and it's interesting thing. Yeah. The last question, yeah. Oh, hi. Okay. Am I right that the first question was about release flags? Huh? Yeah, I tried release flags, and I did not uh, a- add it to the slides because I didn't have enough time to understand how it works. Yeah, because these release flags, they're from it's just guys, I understand. I understand. It, it's just a proof of it's just a proof of concept. It's just a I, I just played with that, you know. Huh? Hmm? I think so. I think so. I think so. Uh-huh. N- Not last year. It was not introduced last year, but last year was a lot of actions with it. Um, I repeat the question. Is there some Rust developer, professional Rust developer who tried this stuff? Yeah. Um, ye- um, yeah, there is. I know just one professional Rust developer who tried this. He helped me to to try to make this thing works, and I don't know every successful experience of using this stuff right now, but I think that it is going to be. Mhm. I repeat the question. If there are some production ready libraries, I don't think so. It There is something now, but I no. We don't know about nobody. The only thing we know about popular solutions. Hmm. Hmm. Okay. Uh, okay. The last question. Okay. Sorry. Could you please repeat about what? Sorry, I don't understand your question. What about performance? I don't understand what these guys were from.
Yeah, the question is, will the new runtime for Ruby improve Ruby's performance issues, like solve Ruby's performance issues?
It's about my experience. Huh? Okay, I don't have. I don't understand you guys. Sorry. Hmm. Hmm. Okay, thank you guys. I hope you been enjoyed.
Let's clap again. Yeah. Doesn't seem like this is working. Can you hear me through the mic? Is it working? What? I don't want to put it directly to my mouth because it seems like a health hazard. Everyone's. Oh well. Probably you can hear me because we're going to take a break again. After that, then we're going to come back for our final talk about 5, 6, maybe even 7 minutes. Let's see how long it takes everybody to get out there. We have a lot of cheese. We have a lot of cheese. I'm told the mic works again. We have cheese, so please enjoy the cheese and the other stuff out there. We'll come back in like 7 minutes, 5 minutes. I don't know. Yes, yes, more clapping. But we're going to start in about like 30 seconds. See, I told you. There they come. Yep. Okay, so we're going to start here in about, as soon as this trick works, hopefully. Yeah, please shut the door. It's quite unpleasant. Yes, yes, thank you. Okay, I think that's good enough for us to proceed, everybody. Hope your temperatures are okay. After this one, we're going to have the networking part. Looking forward to talking with all of you one-on-one for a long time, at length. But anyway, I'm going to go ahead and, yeah. Can you guys try to keep the door shut? It's very loud in the hall. Please keep, yes, thank you, thank you. Get ready for the third one. Coming in just a moment. Yeah. Yeah. I have anxiety about the door. I don't think it should be open. Okay, so let's move on to our third and final speaker of the evening before we get to this networking stuff. So this is going to be, I want to introduce him now, is Oleg Abakshonok. Yeah? He's a generative artist, and he's going to invite people here. This is not going to involve some neural networks or something like that. It's going to involve people that are programmers, or if you're willing to learn a little bit of code, I think probably everyone here is in that category, to discover creativity through a generative art. So Oleg, do you want to come? Yes.
Hi guys, awesome to see you all here. Today I'm gonna try to shock you with some colorful visuals, and I will give you a different perspective on coding. So my name is Oleg. Some of you may already know me, at least my friends I invited. I've been doing generative art. Oh, this was crippled a lot. I've been doing generative art for almost 3 years now. It's my main job and my hobby. And I also mentor people. My students publishing their projects on cool platforms. And I'm showing you my visuals right now. And besides it, I'm creating a JavaScript library, my own, for imitating pen lines. It's my hobby. All the visuals you've seen so far and you will be seeing on the next slides are all created by my library, and that is 100% code. This one is works. These ones are renderings from one project. It's a highly variative one. It can provide different visuals from one code base. What is this all about? Why I have brought you here today? I want to tell you two main ideas during this speech. First one, generative art is a high demand skill for front-enders. You could amazingly expand your professional skills with experience in generative art, because it's a straight path to those awesome real-time animations on websites, user interactivity, tracking head movement, voice visualizations, and such. And even more, imagine generative avatars for your users on your platform. You can gather all data, all user data from each of your users, and after that you can compile it into some random seed and use this random seed for generating some artworks, and use these artworks like banner pictures or avatar pictures, and with that you can achieve having a platform with thousands of users, and each of your users will have distinguishable and unique visuals without any effort from your side, actually. And the second thing, yeah, it's not only 100% legal, but it's also completely easy to be a generative artist knowing only how to code. You don't need to possess traditional art mediums like painting or drawing. All you need is 2 or 3 months of coding studying, and after that, right after that, you could start creating stunning visuals, which will be looking really great. And even if you don't have ever thought about this, I insist you to try, because especially now, artistic self-expression is seen everyone need, each of us. Whoops, sorry. So let's start from the very beginning. What is generative art? And I ask you to raise your hand, whoever heard about it or knows something about it. Yeah, great to see I'm not the one here. Okay, as stated, generative art is all about creating a system designed to create an art for you. And actually any system could fit this scheme, but we will focus only on code-based ones during this speech. So what is code-specific generative art? More or less, it's all about trying to match visuals you saw on Pinterest with algorithms you found on Stack Overflow. Most of the time, your buggy results will look as great as your visual goals, and sometimes you will even decide to go with buggy version and throw away your initial visual goals. Okay, so we reached the key point of the speech. I want to show you actual demo of how to create an art with code, And I want to set a specific goal for today for us. I want you and me to create or prepare 4 completed visuals, 4 completed projects. They will be simple, of course, but each of them can also be like infinitely modified and extended or such. Okay, let's begin. First thing I want to show you is like one of the most basic drawing functions, which could be used alone for creating some visuals. Of course, you could say that we can use points, but a point can work only where there is ton of them, so it's not really our case. I will show you some code, but don't worry, it will be easier than previous presentations. Okay, this is code used to draw a line in vanilla JavaScript. And I want to show you that I will be basing my presentation on JavaScript, but actually you could create generative art on completely any coding language. It could be C++, it could be Python, anything actually. I'm using JavaScript because I'm more fond of web-based generative art, and it's the shortest way to create web-based generative art using JavaScript. Okay, as you can see, we have 3 lines. First line basing our drawer on start point, then we are stepping to the end point, and then we are rendering our walked path with using stroke, and we get in a line. Sorry. But before we proceed, I want for better readability to wrap this code into function for drawing a line, and after that we imagine that we have in a canvas sized of width and height, and if we want to draw a diagonal line, all we must do is draw like one liner. And after that, we will see a result. I will be using my JavaScript library for this presentation. I like it, and I want to keep in one style. And imagine that this square is our canvas for the sake of the readability. And okay, so we have drawn our line, but don't worry, I won't say right now that this is already an art. For me, it's just a line right now. But what keeps it from being a line? Actually, the problem is we can't get much variativity with just line function. No matter how many times we will reupdate this code, we will see just diagonal line. But our next medium is randomness. It's the bedrock of all modern generative art, at least code-based. And there are a ton of functions which implemented this, but we will use standard JS random function. And as you can see, I'm rolling selection between 0 and 1 using random function, and then storing it's in variable, and then I'm drawing a line, but this time I'm using our rand variable in our y-axis, and thanks to that, we always will draw one point at the top, for instance, and if our starting point at the top, then end point will be at the bottom, and in opposite. And with that, we will now receiving our random line. Like we can observe our randomness, but it's actually hard to observe randomness when you draw in only one line. Because you need to update your code to see something another. So the next thing is patterns, and we achieved our randomness, but what if we will draw our line not once, but say in a grid 2 by 2? And as you can see, we could move further and further and again and again, and each time we will divide our field by 2, and now we are seeing a 32 by 32 grid, and with each step, as you saw, our ability to observe randomness and different coincidences will grow, and now we might see starting to see some connections, like if it's this a maze, maybe it's a maze. It's you to decide actually, but if you want to make, at this point you can start thinking, maybe I want to make it a maze. And after that, you will need to add some forks, because all those passes are now just linear. There are no forks, and you might starting to think about removing some looping structures. There are some structures without entrance, so it's not like a maze part. And if we do that, then we will have not just visuals, but visuals inspired with some ideology, with the idea behind it. And it's starting to become like real art. And how do you think how hard it is? Well, let's see. This one will be the last code slide you will see. I have divided it in steps, and the first thing we need to do, of course, it's define our grid by saving our grid measures in 2 variables. After that, we need to divide our canvas size on our grid size, and after that we will have first cell size stored in the, 2 more variables. After that, we're adding 2 inlaid cycles for stepping on each cell, and the last step, we drawing our random line, which we already used. And as you can see, we're using our first iterator in x-axis and the second iterator in y-axis, and that's it. With that, we completed our first generative project. We create some art, and it wasn't hard actually. It's just 11 lines of code, and my aim was to show you that how it works, and that's why this will be the last slide, because all other projects will look similar, will use similar techniques, and no need to show each project's code. So if you wonder how it could be looking like a few steps more if we decide to improve this thing, well, here it is. We like stepped 2 steps further, and we got a real banger. And yeah, it could be looking a little cheap, because it's like draw a circle and then draw the rest part of the all, but actually it's just 2 more operations. As you can see, I shrunk y-axis for fitting more iterations by y-axis, and I am drawing a polygon using each 2 vertical lines. I'm taking them as point donors for polygon, and I'm using gradient fill style for filling it. And with that, we received more advanced visuals, and it's actually like 20 more lines of code, nothing advanced. Okay, let's go further. Things starting to be really interesting when we begin using curves, because it allows us to create a great variety of complex forms and shapes, all we can imagine actually. And I can talk about curves for like hours, because curve is the main instrument I'm using in my library. But for the sake of keeping it simple, I will be using only arcs right now. And as you can see, I draw some arcs, and we can use this piece in our pattern generator we already created. And with each step, we will be receiving even more and more advanced visuals again. And as you can see, we are growing endless variability with this. And again, we came to the point when we could start thinking what I can improve in these visuals. Maybe we decide to fill some of those forms with like different color in checkmate order and see what we will get. And it really will lead us to more advanced visuals. And I want to remind you that our current accomplishments is actually 2 projects. It's 2 distinguishable projects with different visuals, but we already achieved it. And so let's dive deeper. We already tried lines, we tried we tried curves, and we can compile it into shapes. And now we can combine those shapes, loop those shapes, and so yeah. With this slide, we are getting closer actually to our background visuals, as you can see. And actually, all I do was to like randomly choose neither to draw circle in the cell or draw diagonal line and fill one part of section. And nothing really like advanced again. But I say that we can't achieve really very different looking results with only those 2 shapes. So let's add more shapes. And as you can see, now it's looking better, yeah, but still it's just simple forms. It's like arcs, triangles, circles, rectangles, but we can divide it again and again, and each time it evolve. I can, I don't know how about you, but I'm starting to see some like more general coincidences, like those almost finished circles and so, but actually it's all just randomness and like just pure coincidences. And the only thing that is not random here, I don't know if you can see that or not, but actually there is a filling of all those shapes is made by thing called noise. And if I draw only rectangles, you can see that it deforms in different ways and looking really organic. And with that, we come to our next very important part. It's noise. There are a ton of noise types. It's like fractal noises, simplex noise, Perlin noise, but they actually differ in the algorithm, in the cost of computation. But what is really similar between them is that, look, if we will use a random field and just will fill our canvas with random choices, we will receive like it's actually a mess. Just we can see any general observable sorry, we can see any pattern in it in there. It's just a mess. But if we will use noise, we can clearly see that there are organic looking like patterns, highs and lows, and it's actually just a set of thing is, noise is really easy to use because all we receive from a noise function is a range between 0 and 1, and we can interpolate and map this range any way you can imagine, and we can interpolate it in like a radiance range, or in a color space range, like interpolate 0 between 1 and 0 between 2 and 255. And also we can interpolate like in a clamped radiance range, and there is only 8 directions. Yes, we achieved our goal already, but I don't think that we I think that we missing some important part and like little detail. So who can say what we are missing right now? Color, yes. Thank you very much. And I want to introduce you, like, I guess it's the most important thing in generative art, because color is our guiding star in art, and actually everything like shocking contrasts, shimmering glow transfers between hue spectra and bright accents. Thing is, color can tell us actual stories, and it can point on main details in our art. And I say that if your colors don't work, then no matter what, great detailization, advanced technologies, or like it's not gonna work. If your color don't work, then everything else going direct into trash can, because noise is our main medium. Yes. And I show you. I'm not trying to say that this first left one for you is left. Yes. This left visual is not as good as the right one, but I definitely can say that we can tell more to our viewer with the right one. We can express more diverse emotions and ideas with using our color techniques. And yes, look at this. It's pure joy. It's like something YB from 18s, like a candy. And here it is. I say there are no pictures underneath. It's just noise manipulations, actually. And look how beautiful it is. And our current accomplishments. We achieved. I guess I explained to you how achieve such visuals during this presentation, and it's we create still only 4 projects. I'm don't gonna tell that we create 7 of them, but we create 4 projects, and I illustrated you that they all have amazing potential for wide range of improvements or interpretations, and we can use them whatever we want. And what now? I want you to say what you can do right now, right today, after leaving this presentation, coming home, what you can do to start creating an art with code. And the first thing you may wanna visit is a site called P5 Demos. Yes, P5 is a library for JS for creating visuals, but actually P5 is just syntax sugar, as it said. Like you don't write math.rand or round. You just write in round, and that's all. And I'm actually was starting using creating generative art using P5, but right now I'm writing on Pure.js, and I'm not using this P5 anymore. And this site provides you animated, actually, visuals of many algorithms visual you could use. And besides, after you will walk along them and will try to break them, like you can click on any of those and you will open interactive web editor. And besides of those, you can visit another site. Here is QR. It's a platform for sharing generative art between people, and there are a ton of amazing works. I'm also inspired by many of them. There are different techniques, some of them using WebGL shaders, some of them using integrated AI, really integrated inside of the project. And some of them even using WASM. I don't know how, but it's really a ton of inspiration locked in this site, and I'm offering you to visit it. Yes, and besides of that, you can scan this QR and visit my social networks for like booking an appointment if you have any questions, and I can really give you a consultation like that. And it's actually a QA banner, so I'm finished. If you have any questions, I'm willing to answer. Thanks. Yeah. What again? What do I think about NFTs? I'm actually selling NFTs, so I'm into it. Yes. The thing is, generative art is a hobby mostly right now, because not every platform decides to use generative art and real-time animations on this their website, if they mostly fear that this will cost too much for counting calculation power. And there are not many places where you can convert your hobby into the art right now, but there are many cool platforms for creating generative art and sharing it with people who like your work. And yeah, I'm using it. I like it. Yes. Thank you. Yeah. Text to image. Well, I'm not using it much, and I guess I'm not thinking about it mostly. And I'm actually into using AI. I'm using it most of the time. So when I need to Google something advanced, and I'm just last few weeks I'm deciding to just ask it from ChatGPT, but I'm not really into generating image. Sorry. Yes. Was I using fractals in my art? Yes. I was playing with fractals. Yeah, it's interesting technique, but the thing is, JS and the P5 is a CPU-based language, and it's very hard to calculate fractals because it's a very computative, hard process, and all play with advanced functions belongs actually to WebGL mostly, and I guess that using fractals in JS language is like it's a game. It's just giggling. Yes, thank you. Yeah. So I don't know. Start speaking, someone. Yeah. Mhm. Generative art, what is the definition of generative art, and where it ends when it becomes not generative, like that? Hmm. Yeah, I understand. The thing is, at least I am thinking that the generative art is something that you controlling, and everything that created by actually your system, you created system entirely, and this system creating an art for you, you leading it, and you can apply any changes. You can like on the fly correct some variables and receive another visuals. It's more looks like generative art, and any kind of post processing which is done by some third part systems, well, it could be interpreted like generative art, yes, but I'm not using this interpretation actually because, well, at some point anything could be described like generative art, and like you got a new haircut, and the person who done it to you could also be described as a system, then your haircut is also generative art. Like, yes, thank you. One more, yeah, okay. Well, I'm sorry. This hand was first, sorry. Yeah, sure, no problem at all. I say CPU-based languages, yes, they can provide you great performance, but WebGL or such, and or WebGPU, there are great variety of shader-based languages, GPU-based, and they can perform like amazing calculations in 60 FPS per second, and that's not a problem. And I say that WebGL is not really like hard on. It requires a lot of knowledge in math. Not really, but it's just different. I wasn't. I haven't much experience in WebGL, sorry, but I was surprised how difficult it to start thinking different when you're using WebGL, because if we have variables with some strict like int or floating number in code in like JavaScript, in WebGL we actually have a vector as a variable, and the vector is information from all the screen, and it's difficult to manipulate vectors like from point to point. You're manipulating the information on whole screen at once, and yeah. No.
I just want to say a couple things. Like, give me a minute of your time, please. We have the one more badge for who your favorite question was. I already had to give the other two away because those guys left. But trust me, I gave them to them. I promise. So you'll have to choose. We'll do this after this, but yeah, please follow us on Twitter, Evil Martians. And next slide, we do have some merchandise in the back, like stickers. You can take stickers if you want. We have some socks, but we couldn't figure out a way how to distribute these in a fair way. So if you want some socks, just come to me and I'll hook you up with some socks. Let's see, where's the, yeah, can you go to the, yes. So I've been asked to say a couple things about our projects and products. Any cable, post CSS, image proxy. We've got variable fonts right now and fonts, Martian Mono, Martian Grotesque. Check these out. This is some of our stuff. And we are hiring. This is a link to where you can find that information. Hiring for backend. I was told to mention lightly that we're hiring for front end. I don't know how to do that. I've thought about how to do that. So we're hiring for front end, but like lightly. I don't know how to interpret this. So backend. And evilmartians.com/jobs. You can find the information there. And now we can network. It looks like there's still a ton of cheese out there, so we're gonna have to do something about that. Thank you, everyone. Let's clap for ourselves. Like, thanks for coming. Yeah. Okay, that's all.